There's a saying that space is hard. I'll cover some recent examples of that in NASA maintaining deep space missions, private company lunar landers, and SpaceX testing of Starship. I'll also include a brief summary of a few recent space missions and some notable upcoming missions.
Okay, really, really remote maintenance. 15.6 billion miles away, the Voyager 1 probe is out there. That's the farthest one that we've gotten from Earth so far. You know, it's been traveling since 1977. It's going 55,000 miles an hour. It's way out there, way, way, way past the orbit of Pluto. And it's got some problems. It's had problems for quite a while. But there's one particular one they had to fix. They have thrusters they have to use because they have to point antennas back to Earth, and they also have to orient themselves to sight a star. That's how they know they're going in the right direction. They had some thrusters that they disabled. They gave up on it back in 2004. So they went to backup thrusters. And what's happened is those thrusters are gradually getting clogged up with residues. I think what it's from is there's some rubber seals that apparently decompose a little bit. And so every time they use their thrusters, it clogs up the inlet tubing to those thrusters a little bit more. They were predicting that by this fall, they'd be in real trouble. Now, unfortunately, right about this time, the Deep Space Network that's run by NASA, which has 3 big radio telescopes, is going to be down for maintenance. In particular, there's only one left that actually is powerful enough, and that's the one in Australia. That one in particular is going to be down for a couple of months. And they said, okay, by the time it comes back up, we might have lost it. So we got to do something. So they looked really, really hard at their data, and they concluded that there was probably some kind of a problem with a heater power supply. They heat up, I guess, the fuel before they use it. So what they had to do was send a command to fix it, and it worked. But it was really a risky gamble. The problem is that to be able to turn that heater on, you had to basically turn control over to that thruster. And the problem is if they were wrong and the heater didn't work, there was a possibility of a small explosion, and then that would be the end of it. So they gambled, and they won. There's been a whole series of these. They've had a lot of these fixes. But, it kind of illustrates that, NASA has a lot of purposes, and some of it is this very basic science kind of stuff. It does require some attention and some thought, and we haven't really yet managed to automate all maintenance. And I've worked on that kind of stuff, and it's just hard to do. Anyway, they apparently succeeded on that. I'll highlight another one, a remote fix, and this one's actually kind of a trivial one, but it again illustrates the point that attention has to be paid to a lot of these deeper space missions. Now, the Psyche mission is much newer. That was launched in 2023. And now we're back in territory that really is on the kind of stuff that the National Space Society really is very, very interested in, and I'm very interested in. Because this is basically surveying asteroids that aren't that far away. In this case, for metals, which could be of possible great use to civilization. It could be a massive amount of metal, but we haven't really gone there to find out more information about it. And that's going to arrive in 2029. The problem they're running into is they had ion thrusters, but they still have a fuel. They use xenon, and they accelerate it by ionizing. They shoot it out really fast. There was some kind of a valve failure blocking flow, and they had to switch to a backup line. None of that is necessarily a big deal, but the point is people had to be paying attention and do it. There's other lessons there, too, for people thinking about breaking into careers in the space industry. There's an awful lot of stuff that fails or that has to work properly and be designed properly. And that includes stuff that, people in this room have probably been familiar with. Valves, tanks, fuel lines that clog up, all this kind of stuff. The same stuff that happens in refineries and chemical plants, it happens on the spacecraft. It's not that different. The diagnostics are a little bit different. The physical properties are different because the temperatures are more extreme. But the same lines of reasoning have to be followed to figure out what the heck is going on. Okay, now coming in a little closer to home. 3 different moon missions. These are all launched by private companies. And we've talked about these before, but there's been some new information on a couple of them. The first one was the one from Firefly, and that was the big success. We talked about that. That one's over. But the next 2, the Intuitive Machines one and the Hakuto-R one from Japan, there is new information on those. And we've talked about both of these before. The one from Intuitive Machines, this is the one that tipped over in a crater. And that we knew the last time we talked about this, but they have finally released more information about it. They look like this, as shown in this picture here. It did land successfully. It was sort of a hard landing, but it tipped and fell in a crater. And as a result, the solar cells didn't really collect enough energy, and it ran out of power after 12 hours. And we actually had a picture of that final status. It's not clear how deep the crater is, but here you can see the landing legs clearly kind of up in the air. The thing was tipped on its side. So that was the final status, but we didn't really get a definitive statement about what went wrong. So they said there's a couple of things that went wrong. Laser altimeters, and this has been a problem with an awful lot of these landers almost every time. They're saying there's a lot of signal noise and a lot of distortion in there, and they're going to try to get better ones. They actually were pretty smart. They weren't just using lasers to determine how far from the ground they were. That's the key one, because you have to know how much thrust to apply so you don't land too hard or too softly and waste fuel. They're actually also doing optical navigation, basically looking at photos, figuring out where they are based on known photographs taken typically from lunar orbiters that have taken these pictures before. And what they're saying is, now we're landing near the South Pole, and it's much tougher down there. The problem is, most of the time, the sun is at very, very low angles in the sky, and you get these really, really long shadows. And that makes it kind of hard to get very precise results. And for that matter, the craters just look different. When you're really down there, they look kind of different than they do from a couple hundred miles up. And so they've said, okay, they're going to have better altimeters. They're going to have more of them and various different types. And they're working on getting much more lighting independent. I don't know how they're doing that, but I assume that's more the signal processing more than the sensors themselves. And they're going to get a better crater database. So that was probably kind of a reasonable response. That's their second mission. This didn't even go as well as the first one, but at least they kind of got there and worked for a little while. Now, the Japanese one, again, we talked about this one before, but this one, it took a very, very long route to get there, and it just had landed in June. And it crashed. And what they said was it landed too fast. The velocity was too high. Telemetry had stopped about 90 seconds before they thought they were going to hit the ground. So they got really close to the moon, and then something went wrong. And unfortunately, they don't have a root cause analysis on this yet. The one thing they said was they had trouble with their laser altimeter, and it wasn't updating fast enough. Why that is, whether there's problems with irregular ground not reflecting signals well, who knows? That's something they have to come up with. But it probably does indicate that conditions are simply tougher down there than they have been in other areas. Now, there was a video put out by Scott Manley. He elaborated a little bit on this, pointing out that they just had one laser altimeter. They don't have two, so they don't have a lot of redundancy building, or they can't average the signals to get better estimates. And the thing is, that really only works when you're vertically oriented. But the thing is, the way they slow down, you're coming in over the moon. You're mostly going horizontally, and as you slow down, you want to slow down pretty much while you're still in almost horizontal position, because that way all of the thrust you're applying is going to slowing you down as opposed to just fighting gravity. So their optimal path is to flip vertically at the last possible minute. And of course, if they don't really have good altitude estimates, then they're relying on inertial navigation, error builds up. They're thinking maybe that's part of the problem. So we'll get a final report on this at some point. Okay, Starship. It seems like we're hitting a lot of the problem areas recently. And Starship has its own. There's two new results here. The previous flight test 8, they have an analysis out on that as to what went wrong. And also the most recent flight test 9, which also didn't go well either. So first of all, the old flight test. They released a statement in May saying what happened. They're not saying exactly what. They just said they had some kind of engine hardware failure, and this is in the upper stage, where somehow or other propellant and oxidizer mixed and they ignited. That caused an explosion or fire, and then that affected the other engines, and eventually they lost control. Now, this was different. Everybody said, oh, it's the same thing that happened in Flight 7, where about the same time in the flight, they ran into trouble. And this was different. The other one started with harmonics, meaning there's noise and vibration, and it apparently hit resonant frequencies where things just vibrated too much and shook things apart and broke them. They had actually fixed all of that kind of stuff, at least they thought they had. And they're saying it really started in a different area. That was more toward the top of the stage. This was really right down by the engines. So what are they doing? They're reinforcing the structure. They're tightening some bolts. They put in a new purge system with nitrogen, which they had done before, but apparently they're doing additions to that. If you purge with nitrogen, then you don't get the explosions, even if there's the oxygen and the methane present there. They also improved the propellant drain system. They had some problems with the first stage. It wasn't that bad, but they had some problems there, so they put some extra insulation there so they could get the things ignited better. And they also said they're making changes in the engines in the future. They didn't specify what. And that sets the stage for Flight Test 9, which we just had back toward the end of May. So what were their goals? Well, they mainly wanted to finish the flight tests 7 and 8 that didn't really get a chance to finish. That was the biggest part of it. But the other thing is they had been doing fixes as a result of the failures in 7 and 8. So I wanted to try all that. And they really were trying to test deployment of satellites. They have a strong economic incentive. They want to start launching the bigger and heavier Starlink satellites. They really need Starship to do that. They don't fit very well on the Falcon 9. So they have a strong incentive. They wanted to get going on this, and they tried to do that. Actually, they failed, as it turned out. It didn't even open. They were also going to do an upper stage relighting. They also had hoped to do that in the previous two tests, and they didn't do that. That's important. What's been going on is going up pretty much to orbital altitude and then just coasting on the way back. But they haven't really ever tried lighting these Raptor engines in pure vacuum conditions before. And yet you need to do that if you're going to actually come back out of the atmosphere when you go a little bit higher and that sort of thing. So they need to do that. They haven't succeeded in doing that yet. They had fiddled with the heat tiles. They purposely deleted about 100 tiles just to do some stress testing. They're spending a lot of effort on figuring out what works best for insulating and protecting the craft. And they want to do a lot of re-entry experiments. One thing they did do is on the booster, they reused the previous booster. So that actually was quite an accomplishment. And 29 of the 33 engines were also reused. So they are still working on the reusability part quite well. And they were doing a lot of stress testing.
Just one aside, reusing the first stage booster, this first stage booster for SpaceX is equivalent to the first and second stages of a Saturn V Apollo rocket, reusing the first and second stages.
Yeah.
And so this is quite an achievement, just doing that.
People tend to focus on the fact that they didn't complete the whole thing successfully, but they're doing a lot of smaller things along the way to really make sure that they can actually reuse these craft and do it rapidly. They also went to a more aggressive angle of descent, meaning the direction you're going, they go away from that more to get more friction. The idea being they'll slow it down so they don't need so much fuel to slow down. You got to slow down if you want to come back and land and get caught by the chopsticks. So they're experimenting with burning off more of the energy by getting hotter and hotter. And they also purposely didn't relight one of the engines on the booster. So they were doing a lot of different things just to prove reliability. They did, for the first time, at least get their second stage fully burned. That is, they went through all the fuel that they expected without blowing up, which they hadn't done before. That was a step forward. But still, ultimately, they actually lost both stages. They lost the second stage, they had a leak, and they lost control. So the thing just humbled and burned up in the atmosphere. And the booster disintegrated after its final landing burn. They haven't really explained what happened there. Maybe it's because they've been doing all the stress testing, and maybe they went a little too far in the stress testing. There's that joke. It goes back to an old cartoon in Calvin and Hobbes where the kid asks his dad, well, this bridge says it's rated for 20 tons. How do they know that? And dad says, well, they just keep driving heavier and heavier trucks over it till it breaks. And then they back off, and that's how much you can hold. There's a certain amount of that going on here, I think. Okay, so talk a little bit about recent launches to space. Just a couple I'd highlight here. Amazon's Project Kuiper has been coming forever. They finally actually had a full operational launch of 27 satellites on an old Atlas rocket. In fact, I think they just launched another one like today or something. So they're finally really getting going. They're racing against the clock because their license says that they have to have some percentage, half of their satellites or something, up in the next couple of years. I forget the dates, but the point is they're racing against the clock. Now, of course, everybody realizes, yeah, they'll just beg for forgiveness and ask for extensions, but still, it is something that is driving them. One probably not everybody noticed is the Chinese have launched a sample return mission to an asteroid. So far, only the United States and Japan have managed to pull that off, going out to an asteroid, collecting some samples, and coming back, and they're trying to duplicate that. So they just launched that. They'll get to the asteroid they're going to in 2026, and they'll send the samples back to Earth in 2027. But then they're going to go on. The craft itself is actually going to go on a rendezvous with a comet out in the asteroid belt somewhere. And that's a longer thing. That's like a 10-year project. But it's just a reminder that the Chinese are duplicating virtually everything that the other space powers like the United States have done. And, of course, doing some of it better, like in the case of lunar landers, robotic lunar landers. Okay, upcoming launches that are notable. I thought the Axiom mission going to the International Space Station was going to happen. It's been delayed. They had weather delays. Then the Falcon 9 rocket had a liquid oxygen leak. And now they're really highlighting that they really think the situation is getting worse on the Russian part of the ISS in their module, the air leaks there. So either they're using that as an excuse or they actually are really getting more and more worried about that there's serious problems with air leakage. specifically in the Russian module, which is the oldest module. That was the first one that went up. So, I mean, if anything is going to go, that probably would have been the first one. Another interesting test is that Chinese are about to test orbital refueling, going from one satellite to another. They haven't really announced that as such, but everybody seems to think that's what they're trying to do. They've been practicing a lot of maneuvering, getting craft to come together. And so there's a couple of American satellites. This is up in geosynchronous orbit. They're up there right in that same area watching to see that this really happens. And what everybody thinks is supposed to happen is they're going to come together and actually transfer fuel, which would be something that nobody else has done yet. That's all part of the Artemis program, that they're going to have that so that we can get to the moon, but they're trying it on a smaller scale. Dream Chaser, that's still coming, maybe. Astrobotic has a lunar lander. Rocket Lab has a neutron rocket. All these things are coming maybe still in 2025. NASA was launching a couple satellites to Mars. Originally, that was going to be on the very first Blue Origin launch, but that had gotten postponed because they missed the launch window. That may yet come. Lunar landers coming along. There's a whole bunch of Chinese stuff coming up, one of which includes a Mars sample return mission, the second from the bottom on this slide. That's going in 2028. Now, this is something that we had been planning on doing, and it got really, really expensive, and that's one of the things that got killed in the most recent budget proposal, and probably deservedly so, just because the cost got so out of hand. But this is one where an awful lot of people really want to see those samples, and in theory, it'd be nice to do it before we ever send people there. Well, the Chinese are doing it. So far, when they put these schedules out, they've pretty much been meeting them, unlike us.
I live in Brownsville, just a few miles away from SpaceX, and you're talking about the Chinese and so forth. I've been out there just fishing off of the jetties, and you can see our troops going through, and it's all black ops, no lights. It's heading out to intercept whoever's out there watching what's going on with SpaceX at times. And there was even an RV parked out right next to SpaceX full of Russian spies watching what was taking place there also. So, these things are happening there all the time, and who knows how many are out there. But yeah, I've seen most every single launch, most every single explosion and so forth since it all began. But it's a pretty interesting thing out there.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.